Thank you very much for everyone for coming to this session. This session is about modernizing digital APIs, platform to cloud native microservices. It's a long title, couldn't shorten it actually. Tried very hard. I actually killed a couple of words, but that is that. The safe harbor statement, whatever I'm going to say, yeah, you can read it actually. Okay. So before we jump into the actual content, let me just give you a little context before we go any further. That's about me. My name is Yogi. I live in Singapore. I'm a traveler. I love Spring, engineer. I work at Pivotal. In past, I've worked at companies like Barclays, Standard Chartered Bank. I'm a senior platform architect with Pivotal. I work primarily on some of our global customers, and also some in FSI sector, more regionally in APJ. So this is my first time in Austin, and yeah, it's actually a good experience. How many people have actually come from APJ or other side of the planet? Show of hands. Okay, good. And how many are from Austin here? Any show of hands? Oh, we've got one. Well, great city, thank you, good music. Okay, so this is going to be our agenda. We are going to just understand what exactly are these digital APIs that I'm talking about, why there is a need for modernizing them, and because APIs are already like supposed to be modern, so trying to understand what is that, and how we went about doing it. It's still a work in progress. It's not done. It's still a work in progress. And what were the challenges and learnings, and basically what were the outcomes out of this whole exercise. So this particular migration or this particular modernization case study is actually about one of our clients. It's a global bank. Very specifically, I worked with them in the APJ, and we actually helped in migrating or modernizing their existing tech stack of digital APIs onto a more modern cloud native platform, Pivotal platform, and Spring Boot mainly. So why was it necessary? What were their challenges? We'll be talking about that today. So what are digital APIs? Digital APIs, it's more of an internal term that the bank actually uses. Digital APIs are basically something that the bank uses for delivering customer experiences as well as some partner integration. So if you are a bank customer trying to use their mobile banking app, you are actually using these digital APIs. If you're a partner who's actually trying to leverage, say, wallet-based payments or wallet top-ups, or even redeeming, say, your flight reward points and things like those, you are also using the digital APIs. So that is the whole portfolio of digital APIs. So APIs themselves, like if everybody know about digital transformation, it's all about moving to a more API-centric approach, whereby you are exposing your own capabilities out to others, customers, or even partners, and leveraging your existing workflows, your intelligence, and monetizing it in some way or the other. And you do that through APIs. So APIs are already a very modern way of implementing software. But this is like modernizing the APIs themselves. So what is this whole thing about? Well, the API modernization project actually is rooted in a much larger project of an organization-wide digital transformation project, whereby the organization has adopted approach to go more cloud native, more microservices oriented, remove all sorts of blockers while delivering any experience. So that's why the need for modernizing the existing APIs themselves. One of the key drivers, there are 5 actually. One of the key drivers in this whole process was the organizational change. The whole organization is undergoing a shift from a more project-centric approach to a more product-centric approach, whereby unlike you have a start and a finish for a project, whereby the team, if you've worked for a bank or if you've consulted for a bank, you would know a project is funded, the resources are allocated, they deliver something in 3 months, 6 months, or 9 months' time, and that's it. The team is actually disintegrated, and they move on to, each individual move on to a different project. So first of all, that kind of a thing results in a lot of technical debt to begin with, and a lack of ongoing enhancement to the existing experiences. And that's exactly what a product-oriented mindset brings in. It gives you the ability to deliver something, learn from it, and iterate, and deliver more. So that was the first key driver from a project to a product mindset. The second one is the way teams were actually organized. They were very, very business function oriented. So whereby if you think about, let's say, a CASA or a savings bank or a credit kind of a transaction, you would actually have separate teams kind of doing it. Whereby from that kind of a team organization, they move to a more domain and a subdomain kind of an organization, where you have some sort of guiding principle at the domain level, and then you have each individual, each team, which is sort of driving a subdomain within that. So think of it as credit card being a domain, and say, for example, some of the virtual cards that you see nowadays, like with Apple Pay or Google Pay, those being, say, subdomains. Agile software delivery was another key driver in their transformation journey. So to have sustainable teams, teams which are able to deliver at a consistent pace, have more visibility, and reduce the firefighting that teams might undergo in a project kind of a mindset. That also was something of a key driver. Having a team which comprises of cross-domain individual people who are really knowledgeable about the business itself, becoming product owners within the team, and providing important insight for doing what they are doing. And then moving away from developers building something and passing it over to the operations, or developers building something and then a testing team actually building out test suite for this. That entire sort of pipeline was revamped to be a more holistic, sustainable team. There was, because this particular organization, it's a large organization operating well over hundreds of teams actually. Typically, it's in a smaller organization, you would want a so-called DevOps team to be self-sustaining, doing the ops as well as development work together. But in a larger organization, it may not be practical at first. And hence, there was a DevOps delivery team. So there was a central DevOps kind of a team that is providing with certain automation capabilities, and individual product teams are leveraging on those capabilities to deliver their solutions and experiences. In terms of enhancing or taking their digital transformation strategy forward, they have gone for a very, very important mobile-first kind of an analogy, whereby every experience that they are going to build is going to be built first for mobile and then for other channels, which was earlier like, okay, build it out for our in-branch system or in-person systems, and then maybe expose it over internet channels, and then, if time permits, do something with the mobile. Now, the strategy is shifting to be mobile first. And leveraging microservices to actually deliver all their experiences, so that any sort of blockers due to convergence, I'll come to that particular point a little later in the presentation, but using microservices to be able to deliver these experiences seamlessly, autonomously. Also, something that the bank actually realized very early in the journey is that for a decent amount of time, they are going to have a two-speed system. You have system of records. How many of you all have worked for a bank? Show of hands. Wow, quite a few. Yeah, I too have worked. So you're going to have system of records which are based on mainframes, and it's very difficult to sort of enhance them or even retire them at the moment. And it is what it is, and we have to work with that. Heritage actually is paying the bills, right? So we can't just throw it away. We have to keep it running. So in terms of digital transformation, a two-speed architecture was kind of understood and taken as the reality of today, and then moving forward. Also, having a cloud journey was part of this entire digital experience that they are trying to transform. So adopting a more cloud-native architecture where applications are developed independently, delivered independently, and are managed pretty much all on an autopilot mode, you can say, in a cloud-native way. Leveraging platform from Pivotal platform, and using the open source technology, unlike their existing stack, which is actually not an open source technology. So the four things that I mentioned so far, one was the organizational change, the cloud journey, digital transformation aspect. They were more strategic. This was a more technical thing that they needed to cover. They had some operational challenges with their existing stack that they were absolutely trying to mitigate. One was their existing stack really didn't have a clear upgrade path. They were running on a version, and if they were to go to the newer version, it would require a significant rework. There was no clear path. You want to move things to cloud, but if you are going to use the cloud version of the stack, it would take almost the same effort as building something out on another stack. So this was an operational challenge that they were actually facing. So through this particular transformation or modernization, they've actually addressed this. Real-time scaling was another challenge that they had. You have APIs, and operationally you had to do the capacity analysis beforehand, and if you want to scale any individual API, first of all, that was not even possible because of the way things were packaged and delivered. The second thing was you would have to raise a change ticket per se, and that would go through the change delivery or change management process and could take significant time. If it is something that is urgent, probably you could get it done faster, but it wasn't real time. There was a process involved in this whole case. So that was an operational challenge that they were struggling with. And the continuous delivery aspect. The way the current stack was organized for optimization purposes, each individual API would actually be delivered and then packaged into a single package, making it like a large modular monolith per se. But each individual API would come from a different team. When it comes to delivering, all the API teams would have to really converge to this packaging, which is like set on a particular date. Packaging gets done, and then the delivery begins. So if you had to deliver anything, any smallest of the enhancement, well, guess what? You get into the release train, and you would have a release maybe in a month's time or maybe in a 3 months' time. So continuous delivery was not even something that was possible with the current stack. So these were the key operational challenges, more tactical, but had to be addressed. So how did we go about doing it? First of all, any digital transformation journey is not going to be successful if you don't address the people aspect of it. So the bank actually realized it very early that, yes, we really need to upskill our people, reorganize them, because people who were running the existing stack, they came from like a 15-year kind of an experience on the stack, which is like more or less proprietary in nature, onto something which is more cloud native like Spring Boot or Java. So that was definitely going to be challenging. Yet there was attention paid in upskilling the people and also utilizing their intelligence and insights into the existing API ecosystem to deliver these modernized APIs. the existing developers, engineers, architects were actually upskilled. They went through a few week boot camp to learn about Java, Spring, Spring Boot, Spring integration, and then they actually assumed role of SMEs in these deliveries, in these teams, whereby they were actually able to help in building out the test harnesses and also providing insights as to how the APIs are actually used. For example, where in the year you could actually experience certain spikes for certain set of APIs. Like for example, near Christmas, you are going to actually experience a lot of spikes for a particular set of consumers. So you need to certainly scale them accordingly. The teams were actually organized with people from multiple layers of the organization, if I may put it that way. So it was not just people who were doing only APIs or only doing backends. You had teams which had really cross-layer team members who had good intimate knowledge of, say, the databases or even the messaging systems and also the integration layers. The second thing that was important in this delivery was the adoption of CI and CD and DevOps practices. Earlier, the challenge in achieving a continuous delivery ready architecture was everything was fairly manual. You had somebody who was coordinating all these releases, chasing people, chasing individual teams. Hey, is your artifact ready? Can I actually put it out for packaging? If it is not ready, when it's going to be ready? So you would have challenges like those, versus any one API today has its own source code repository. It has its own automation pipeline. The moment somebody checks in a piece of code, it goes through the rigorous pipeline where the source code is compiled, packaged, tested. Even security scans are performed on it. These security scans and code analysis results are actually present and published and tracked. That actually leads to the last point on the slide that you can see is about rewards and recognition, whereby anybody or any team or any individual who's actually producing a higher quality code is actually rewarded for it, is recognized for it. So at like company tech talk events, at like quarterly town halls, people who had well-written or well-organized and well-tested code were actually recognized for their effort. And that actually led to a more of a like gamification of this entire journey, whereby people were literally competing to actually have a much better covered code, much better quality code. The thresholds for quality were set to be very, very high. So in some cases, for some of the APIs which were deemed as critical, the code coverage was put to be around 90%. So you had to have 90% test coverage on those APIs. It was not like across the board, but something that is deemed critical would definitely be put into that. And for a larger effort, because this was like almost a 70 different team kind of an effort, you really needed some very, very clear guidelines about how you are going to design your systems, how you are going to actually implement these APIs. So of course, automation like use of CI/CD becomes important, but because you are trying to modernize an existing API, the very first thing was the consumer contract should not change. Whatever the API is, whatever is the behavior of API today, when you move to a more modernized stack, it should not change. That was like literally the first rule that was laid down. There was a lot of emphasis on test-driven development. Everything that you're going to do needs to be testable. Otherwise, you are not going to be even able to put it through the pipeline. It would just get stuck. The builds will keep failing. After analyzing the API stack or API portfolio, there were there were certain areas which were very, very repetitive. Very specifically, there was one pattern that was recognized, it's like scatter-gather pattern. It was very common across the entire portfolio. And implementing that correctly in all these 70 sort of, or like by the 70 teams, it may vary because each developer has their own preference. So there was this emphasis on centralizing some of these patterns and emitting out a library that could actually be helpful in implementing the end API quickly. So that was something that was also done. Again, it also helped in minimizing the developer productivity because minimizing the impact on developer productivity because the current stack had a more, it was a low code or a no code environment whereby you could drag drop things and make some workflows and implement an API. Whereas if you are going to move to a more code centric Spring Boot or Spring integration stack, well, there is learning, of course, and yeah, you could also have bugs, right? So first thing was bootstrapping people into these cloud native platforms. Second, yes, emphasis on the test driven development, but also the common library for common patterns helped in minimizing the impact of this change. Boilerplate code avoidance was also something. So like Spring Boot starters were actually leveraged for avoiding all sorts of configuration management to be done or hard-coded or done on your own. IDE integration with things like SonarQube were leveraged for ensuring that code quality is tested early within your machine itself. You don't have to wait for your code to be checked in and go through the pipeline to find out, hey, your code quality is low. You do an early integration with SonarQube to ensure that the code quality before even you check in is very, very high. The debugger integration within the IDE was also very, very useful in understanding the code flow because, again, the developers, they were actually coming from a low-code, no-code kind of an environment. So to be able to actually dig inside the API calls was very, very useful. The old stack was a more message-oriented stack. So, and it did have a lot of capabilities because it's like 10, 15 years old stack. One of the guiding principle for selecting the portfolio, we in this particular engagement, we've implemented about 8%. We've managed to move about 8% of their critical APIs onto the new stack. So that would still leave a significant amount on the older stack. And going in and out of that older stack could be time consuming on a data path. So avoiding that was always something that was highlighted upfront. So anytime you want to analyze, okay, which are the APIs that we should go out for first? Well, does this mean that you will have to be going in and out of the old stack? No, yes. That became like a litmus test for this whole thing. But then again, even after all these guardrails, you have debuggers, you have code quality checks. After all these things, you would still be left with the risk of what if it doesn't work? And it's a bank, so that is a kind of question almost everybody would ask. And that's where controlled traffic migration was proposed very, very early in the engagement. That is, you have an existing version of the same API running on the old stack, and you're going to re-implement it on the new stack. How do you actually regulate the traffic? Kind of a kill switch. If my API is somehow misbehaving, not functioning properly, how do I ensure that immediately I'm able to actually move all my traffic from the new API to the old API? Or you could go more granular, which is I only want to move a certain region, a certain country to the new API, or a certain segment of the market, so a certain segment of the customers onto the new API. Those were the kind of controls that they needed to ensure that in case of a problem, they are actually able to move between the old and new. So this is how the end state as it stands today looks like, whereby the partners and the customers, they converge onto the API, onto an API gateway component. The banking services backend is something like if you're using mobile banking or internet banking, there are existing systems around it. And those systems, they are becoming clients to these digital APIs. They are already a client to these digital APIs. They converge to an API gateway. From the API gateway, the selective or controlled traffic routing that I mentioned earlier was actually implemented in this API gateway, whereby they are able to define very clearly only a certain segment or only a certain market or only this % of the traffic can go to the new stack against the old stack. And then existing stack is already connecting to the enterprise services. The new the API implementation on the new stack was done using Spring Boot and Spring integration, whereby all sorts of connectivity to the enterprise services like LDAP or databases or messaging queues, all of this were actually provided either by Spring integration or by PaaS, the Pivotal Application Service. So in this whole journey, what worked very well for us? First of all, if you remember the operational challenge about being able to scale a single API real time was not even possible. Now, any individual API can actually be scaled up or scaled down, and that too, they are actually using autoscaler in Pivotal Application Service. So when the APIs are receiving very, very high traffic, they're able to scale up automatically, and once the traffic actually dies down, they actually come down. Even they've even set up rules around latency. So you may not have high volume, but if your individual API calls are taking longer to process, then scaling them could make them go faster. Each API is continuously continuous delivery ready. Earlier, you had like developers could implement the feature very, very quickly, maybe like in few hours, but they wouldn't be able to deliver this because all the individual workflows have to come together, get packaged, and then get delivered. So now that is not the case. Any developer, they just have to commit their code. It goes through the pipeline. It gets code scanned and everything, and then based on the change ticket, they can just release that single API. They don't have to wait for any other API to release. The adoption or implementation of a core or a helper framework actually helped. That allowed the teams to not worry about some of the common concerns and just leverage the API. It kind of became like an internal API. So for example, for connecting to databases, the discovery of the actual database, it's based on, there is a process involved with it. So that particular implementation was put inside the common library. All the teams, they actually use that library to discover this now. A lot of rework for patterns like scatter gather was avoided through the use of, again, the same common library that was established. And the controlled rollout of traffic or controlled rollout of APIs also helped in rolling out the new APIs on a per region and a segment basis. What we learned in this was, yes, people do have a learning curve, right? But initially, when there was a POC done for this particular engagement, the effort was estimated to be higher than the existing stack, like significantly higher, 4 to 6 times higher. But still, because the guiding principle was that, yes, we need to be more cloud native, we need to go and use more open source technology because of the ecosystem and the community, the project was kicked off. During the implementation, the actual effort is almost the same now. On the existing stack, the metric was around 3 days for each API. On the new stack, they managed to deliver about 82-ish APIs in about 6-7 months. That's like roughly about 2 APIs per day. Oh, sorry, 2 days per API. So that was a good learning. That yeah, I mean, estimates are estimates. The actuals will differ. The power of open source community was really highlighted in this particular engagement, because whenever we ran into the issues with Spring integration, we would actually just go to GitHub, look through the issues, go to Stack Overflow, look through the posts there. The Spring advisory team, a shout out to them. They were very helpful in this as well. We would actually file issues even on GitHub, and not just the Spring advisory team from Pivotal, but the larger community would actually respond to them and actually guide us. Like, this is where you are using the pattern incorrectly. You should probably correct your usage. And that was very helpful, and it was very fast. We would post something today, within a couple of hours we actually would see some replies. Configuration drifts. This is something that we actually all along we thought that it's going to be fine, and for most part it was. Key thing that we ran into, and this was actually on the rollout day, DNS configurations. So the DNS configurations on the virtual machines was set up to have a lookup domain. So if, let's say, your application is using just the host name and not the fully qualified name, the system will just work. But on a platform like Pivotal Application Services, you have to be very precise about it. You should be using fully qualified domain names. So that is something that came out. I mean, we were able to resolve it in like a couple of hours kind of work, but yeah, I mean, it did pose a problem during rollout. Releasing early and releasing often really helps, because when the library was being developed, library and the consuming APIs, they were like simultaneously developed. So they were able to release very often both sides and quickly collect the runtime details around it. Is it going fast? Is it too slow? Is it behaving in the environment correctly? Those things they were actually able to do very easily, very quickly, and that actually helped in accelerating the whole delivery. These are some of the benefits that the team has seen from this entire engagement. They don't require any more change tickets for scaling their application. That in itself was a huge thing. It actually reduced so much of stress on the team, because now if you just have to scale, you don't even have to worry. It will just scale. It's set to auto scaling. They are able to actually deliver enhancement within days, which earlier could be easily like few weeks or maybe months, depending on which business function the API is sitting in. The feedback loop has become much shorter. Now they can actually see, if an API that they have implemented individually, if it is being used more, maybe they can invest more time just enhancing those. We've migrated about 8% of the APIs, and they are handling about 10% of the traffic through across the entire portfolio. So this was not like a small bunch, and it was not a big bunch. It was just like right sized. So at least we were able to depict that with this particular modernization effort, we are able to actually move to a modern stack. We can actually take challenges and deliver it. And change failure risk, which was always a concern from the change team or change management team, was actually mitigated or addressed through the staggered rollout policy that we adopted. With that, thank you very much. If anyone has any questions.
How did your canary testing? You said you do canary deployment.
Yeah, so canary deployment, canary deployment is not in the sense that PAS does the canary testing, but this is actually across 2 stacks. So now we are actually able to introduce the new API and still route traffic into old and new and see how it is behaving. If, let's say, the API on the new stack just crashes at the time of arrival because some firewall rule is not functioning properly or something.
How you implemented it by DNS?
No, this was implemented within the API gateway. Because we are able to selectively route the traffic, say based on the user context actually. If the user is from a certain country or a segment or something like that, we could do it. So we actually started out with, I'm being very careful without giving out too many details actually, but based on segment, frankly, based on segment, yeah. So, I mean, from that perspective, it was an easier task because actually these APIs lie mostly in the experience API bucket, if I may put it that way. So that was an easier thing. So because, again, when you're building a new application, that figuring out that part is challenging. But the advantage that we already had an API. We already had an API implementation. So it was merely rewriting this on a newer stack. So, I mean, those were some of the advantages that we had to begin with. So didn't require a whole lot of education. Okay, thank you very much. I'm going to be here for today and tomorrow. Catch me in the community hub. Thank you very much. Thanks for attending.